That math test was so hard.
Welcome to MathBusters, where we bust the myths about math for you. I'm Vedanth Chakravarthy.
I'm Aadit Vedanth. And let's get started.
Here we have the sine function right here. It's a pretty simple function. We can see right here the period is where the pattern starts to repeat. So we see it goes up at 0, and then it goes up again at 2 pi. So we see the period is 2 pi. Then we have some unit circle from these right here. Pi over 6, 30 degrees. Pi over 4, 40 degrees. Pi over 3, 60 degrees. But then the circle right here, sine is the y value. So for pi over 6, 30 degrees, the y value is 1/2. Sine of pi over 4, which is 45 degrees, root 2 over 2. And sine of pi over 3, 60 degrees is root 3 over 2. Those are the sine values respectively. Then we can see the pattern exists right here because as you go from 0 to pi over 2, we see that the y values are actually going up. We see 1/2 root 2 over 2, root 3 over 2 is going up. But then again, as we approach from pi over 2 to pi, we see the y values going down because the unit circle is going like in that direction. We'll have pi over, root 3 over 2, root 2 over 2, 1/2 is all going down. Then we go to the cosine function. The cosine function is sine of pi over 2 minus theta or sine 90 minus theta. We can see it's just a shift left or right of pi over 2. So that's why we have the period here is the pattern starts to repeat. We see negative pi here, pi over here is when it starts going up as the rise of the period is 2 pi. And we can see again, we start plugging in values here. We see pi over 6, 30 degrees. This is the x value. The cosine is the x value. That's why it is root 3 over 2 for 30 degrees, root 2 over 2 for 45 degrees, 1/2 for 60 degrees. And then again, as we go over here, the x values are going again in the left direction, which is why cosine from pi over 2 to pi side is going down.
This is the tan function right here. The tan function is the ratio between the sine and cosine function. Right here, you can observe that the tan function has the asymptotes at pi over 2 and negative pi over 2. That's because as cosine reaches pi over 2, it equals 0. You can't have a zero. You can't have 0 at the denominator of fraction, as that's undefendable. Right here, you can look at this mnemonic right here. We have all students take calculus. So whenever we have a value within the first or third quarter, that's going to give us a positive value, while we have a value in the second or fourth quarter that's going to give us a negative value because either sine or cosine are going to be negative.
Okay, here we have the inverse functions of the original three trig functions. Starting with cosecant, which is the inverse function of sine. We can look at when sine is equal to pi over when sine is pi over 6, we have 1/2, and when cosecant is pi over 6, we have 2, since we're just flipping it over. Looking at the graph right here, we have the original function for sine and function for cosecant. You're just looking at the apexes, and you're going to flip them over, and then you're going to have the asymptotes at pi, 0, and negative pi, because it's going every pi for pi over n, pi n. And then moving on to secant is the same concept as cosecant, except it's the inverse function for cosine. If you look at pi over 6 for cosine, you have root 3 over 2. And if you take that for secant, you have 2 root 3 over 3. Again, just flipping them. And if you look at the graph here, we have the asymptotes at negative pi over 2, then pi over 2, and then down to pi n.
Yeah. So here we have the cotangent function. It's possibly the easiest. It is the inverse of tangent function. So we have 1 over the tangent theta. Then as we know, tangent theta is sine theta over cosine theta. This is simply cotangent theta is cosine theta over sine theta. So we are simply flipping the equation. So we have right here, this is the cotangent function, but the tan function with the original one would be something like this, right here. Then on this side, like this. You get the point. So it's basically, this is the original line for cotangent, and since the original line for tangent is this blue one right here, and since it's flipping, the black one is the new one, so we're just flipping the x-values. If we have the cotangent values in the table, this is last but not least, we have the tangent value of this. So tangent of 30 degrees is simply root 3 over 3. But then we flip that, we get 3 over root 3. We simplify that, we get root 3. We're just flipping the tangent value.
Okay, now we're going to apply our skills that we learned earlier to an actual problem. That's actually pretty easy. So our problem is secant squared x equals 2. How do we solve this? It's pretty simple. You just take the square root of both sides. 2 over 2. What is the x value for plus or minus root 2 over 2? It's actually pretty simple because from earlier, we know that pi over 4 is the value that gives us positive root 2 over 2, which is right here, cosine root 2 over 2. But we also have the negative value for that, which is just from the other side.
Again right here, and again right here. Which gives us 4 points, specifically in a domain restriction of 0 to 2 pi. So that gives us x is going to be equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.
A drone is programmed such that altitude at time t seconds after the beginning of its performance is represented by the following trigonometric equation. H of t equals 450 plus 50 sine t minus 5 times pi over 20. Suppose the performance starts at t equals 0 seconds. At what times will the drone's altitude reach 500 feet during the first minute of the show? First step. We want to know at what times is it 500 feet. Set at 500. Set equal ht equal to 500. 500 equals 450 plus 50 sine of t minus 5 times theta over 20. Subtract 450 both sides. 50 equals 50 sine
Of t minus 5 over 20. T minus 5 5. Then divide 50 by side. 1 equals sine t minus 5 pi over 20. So we're in a circle, and let's find out at what value is sine.
Let's continue. So we know that sine is equal to 1 at pi over 2 plus 2 pi k, where k is an integer. So we set this value inside of the sine equal to pi over 2 plus 2 pi k, where k is an integer. So k equals 0. If k equals 0, we have t equals 15 plus 40, 0, which equals 15 seconds. That fits within our 1 minute as defined right here, the first minute of the show fits. So let's say k equals 1 now. T equals 15 plus 41, which 40 times 1, which is equal to 15 plus 40, which is 55 seconds, which fits in our minute. Let's go with k equals 2. So we have t equals 15 plus 40 times 2. 40 times 2 is 80, so it is 95 seconds. But we know 95 seconds does not fit because that's the first minute, first 60 seconds, so 95 seconds is not an answer. Thus, our only answers are 55 seconds and 15 seconds.
Thank you for watching this episode of MathBusters.
Please like and subscribe, and make sure to share with your friends, and make sure that you get a good score on your test. Stay notified.